Good morning, my lovely kiddos and my future mathematicians. Today we are going to be talking about 8.1b, and that is similar polygons and scale factor. All right, so first let's talk about similar polygons and what they are. So similar polygons are two polygons or two shapes whose corresponding angles are congruent. Corresponding angles are congruent. And whose corresponding sides are proportional. Okay, so let's go ahead and get some practice with that. I'm going to go ahead and draw us some figures here. So we're going to have this triangle here with points E, F, and G. And a second triangle with points A, B, and C. And let me draw the congruency markings. Okay, so we know pretty well how to prove or how to spot corresponding congruent angles. Okay, so these are just angles that have the same, that are in the same place that have the same congruency marks. So we can see that angle E in this first triangle is congruent to angle A in the second triangle. Okay, so I'll say angle E is congruent to angle A. Okay, we can see that angle F is congruent to angle B because they're both 90 degrees. So I'll say angle F is congruent to angle B. And finally, we can see that angle G is congruent to angle C because they both have two strikes. So angle G is congruent to angle C. Okay, so that's pretty easy finding the corresponding congruent angles, but how do we prove that sides are proportional? Okay, so we are actually going to have to use a different definition here, and this definition is the scale factor. Okay, a scale factor is the ratio of the lengths of the sides of the two similar polygons. Okay, so up in our example here, if I say that the corresponding sides of E to F, the one strike to the 90-degree angle is 4 units. And then on the larger triangle, that A to B from one strike to the 90-degree angle is 6 units, then we could use those side lengths in a ratio. Okay, so remember that ratios, we can either write them on top of each other, 4/6 kind of thing, like a fraction, or we could write them next to each other with a colon in between. In either case, we need to go ahead and reduce these, and the most reduced, that is the scale factor. Okay, so if we reduce this 4/6 by dividing both the numerator and the denominator by 2, we get 2/3. Okay, for either case, we get 2/3. Okay, and that is the most reduced. So this is our scale factor to get from the smaller triangle to the larger triangle, 2/3. Okay, So let's go ahead and do an example here to prove if two polygons are proportional or not. I'm sorry, are similar or not. Okay, so we have triangle EDF, where E has 2 strikes, F has 3 strikes, D has 1 strike. E to D is 9 units, D to F is 12 units, and E to F is 16 units. On the other triangle, we have points Y, X, and Z. Y has 2 strikes, Z has 3 strikes, X has 1 strike. E to D has 6 units, X to Z is 8 units, and Y to Z is 12 units. So first thing we have to do is we have to check, are our corresponding angles congruent? Are the angles in the same spot? Are they congruent? Okay? So we can see that angle E and angle Y here, they are congruent because they both have 2 strikes. So I'm going to say angle E is congruent to angle Y. We can see that our largest angles, angle D and angle X, are congruent because they both have 1 strike. So I'm going to say angle D is congruent to angle X. And then finally, I'm going to say that angle F is congruent to angle Z because they both have 3 strike marks. Angle F is congruent to angle Z, not D, Z. Okay, and then now, since we have shown that our corresponding angles are congruent, okay, now we have to check if our corresponding sides are proportional. So first, let's write down the corresponding sides. Okay, so if E and Y are corresponding angles and D and X are corresponding angles, then E to D, this side, must correspond with Y to X. So I'm going to say ED and YX. Okay, so D to F, or D is corresponds with X, F corresponds with Z. So DF would have to correspond with XZ. So I'm going to write DF and XZ. And then finally, our longest sides, E corresponds with Y, F corresponds with Z. So E to F would correspond with Y to Z. So EF and YZ. Okay, so let's go ahead and write down these ratios to see if they simplify to the same scale factor. We want them all to be the same, because if they're not the same, then these are not similar polygons. Okay, so E to D has a ratio of, or is 9 units long, and then Y to X is 6 units long. We want to go ahead and reduce that, so I'm going to divide by 3, and we get 3 over 2. Okay, so from ED to YX, we get a scale factor of 3/2. For DF to XZ, we have 12 over 8. Okay, we have to reduce this. I'm going to divide by 4. 12 divided by 4 gives us 3, and 8 divided by 4 gives us 2. So once again, between these two sides, DF and XZ, we once again have a scale factor of 3/2, which is good. We are 2/3 of the way there to proving that this is a similar polygon. These are similar polygons. Okay, so this last one, EF and YZ, let's go ahead and write that down. We have 16 to 12. I'm going to reduce this, so we're going to divide by 4. 16 divided by 4 is 4. and 12 divided by 4 is 3. Since we cannot reduce this any further and it does not match the other two scale factors, it just throws the whole thing off. These are not similar polygons. So we need to find our corresponding congruent angles, and then we have to find the scale factor for all of the sides and make sure that they all have the same scale factor. And since this last one does not, these are not similar polygons.